So in the previous few lessons, we have talked about different types of relations like symmetric, antisymmetric, reflexive, etc. So in this session, we are going to talk about another special type of relation called the transitive relation. Now, before we see the mathematical definition, I'm going to start with a very simple example. Suppose any person P is related to Q, provided Q is taller than P. Similarly, suppose Q and R are related. So basically, R is taller than Q. So it's a very simple relation that we have taken based on the height of the person. Now, what is basic transitivity? So this property is getting transition via a middle element. Now, the obvious thing we understand from this is P will be actually related to R, because R is basically taller than P. So this property is actually known as the transitivity. Mathematically speaking, suppose you have this element A comma B and also another element B comma C. This will imply that A comma C will be there in R. So this is the kind of transition we are having. A and B are related, B and C are related. So the property is getting transition from A to C via B. Always remember, whenever you're checking transitivity, you need to check pairs of the form AB and BC. So the second component of the first pair should be equal to the first component of the second pair. Now let's take an example. Very simple. I have taken this example of a relation R on the set A, which is PQR, and there are the ordered pairs in R. So what we are going to do is take every element and check the kind of elements we have for transitivity and also see whether the kind of element we are looking for is there or not. So basically, I'm going to start with P comma P. So whenever you think about P comma P, you look at the basic forms which are starting with P. Now this is P comma R. So you check that P comma R is present. Now you don't see any other pair starting with P, so we are done with P comma P. Now let's look at P comma R. So what are the elements which are starting with R? You will notice that the element starting with R is R comma R. So basically these are the two things we check for. So for PR, we have RR. So PR should be there, which is perfectly okay. Now there's nothing else which is starting with R. So we move on to the next element, Q comma P. So we have P comma P, for which this Q comma P is present. We have Q comma P, P comma R. So obviously Q comma R is present. So there's nothing else which is starting with P. So we are done with Q comma P. Then we move on to Q comma R, for which we have R comma R. So obviously Q comma R, we check that it's present. And finally, when you move on to R comma R, you don't see anything else starting with R. So you don't need to check this. So I hope you understand for a roster form, what are the kind of basic necessity you have for checking the elements of the form AB, BC. So you have to check whether AC is there or not. Now, whenever it comes back to the set builder form, it's very important to understand the generic procedure. Here we have taken a relation capital R on the set of all real numbers given by X is actually related to Y via R, provided X is less than Y. And here by less, we mean strictly less. Now what we are going to do here is very simple. You take any ordered pair of the form A comma B and other ordered pair of the form B comma C. Now you have to show that A comma C will belong to R. For that, I'm going to explore the definition of the relation. So A is less than B. Similarly, B is less than C. Now algebraically, if you manipulate them, you will clearly see that A has to be less than C. Now we again explore the definition of the relation, which tells us that A and C are related. So A comma C, that pair is actually there in R. So what we observe here is from AB and BC, you have AC in R. So this is actually transitive. So these are the kind of things you have for transitive relations. Now I'm going to take another simple example. So again, we have taken a collection of sets, which is given by S, and one set is related to the other if it's a subset of that. Now, suppose I have A being a subset of B and B being a subset of C. you can clearly say that A is a subset of C. So this is very basic set theory, and you will see how beautifully the property of being a subset is transitioned from A to C via this element. So this is a transitive relation, and this is the essence of transitivity. So I hope you understand the basic definition and how to check transitivity. So practice some sums from here as well. Look at the examples. And in the next video, I'm going to talk about another special type of relation called the equivalence relation. So stay tuned.